Hello everyone. So now that we know how does the basic setup for the spice looks like, the next step is to write down the spice netlist in the correct syntax so that it's taken very well by the spice engine. So it's like a C program. Every engine, every software language has got its own syntax. Similarly, the spice also has got its own syntactical way it understands things, and we'll do the same thing. We'll write down the spice netlist for this particular circuit and see and try to simulate it. So, okay. So let's try to start with the writing down the spice netlist. The first step in doing that is to defining the nodes. Okay, so what we do for first of all, before even defining nodes, let's give some values to these ones. So for example, let's call this one as 2.5 volts. Let's call the protection resistance as 55 ohms. Okay, it's called as R1. Let's call M1 be of a width of 1.8 micron and length of 1.2. This is basically W by L. Okay, so 1.8 by 1.2, and your VDD is 2.5 volts and VSS is of course 0. So this is what we have defined, and now we have to put this in a way that is being understood by the spice engine. So the first step to do that is to create nodes. Now let me tell you what do you mean by nodes. So now for example, if you want to define this R1 in a spice understandable language, it has to be defined in such a way that it's present in between two nodes. So from this point till this point, if you trace along this particular wire, there is no obstruction from this point to this point. Similarly, there is no obstruction from this point to this point, and after this point comes your voltage source. Okay, and after this point comes your transistor. So this particular thing or this particular thing forms one node. Moving on, for example, let's say you have this voltage source. From this point you just keep on moving, and there is no obstruction from this point till the VSS, in fact till this point. Okay, so these forms the second node. Once you go to this power supply voltage, for example, from this point till this point there is no obstruction, so this forms your third node, and so on. So the first step is to define the nodes, so that we define the components in between those nodes. So let's look into that. So these are our nodes. You have this node, since there is no obstruction from R1 to voltage source. You have this volt VSS as one of the node, because this point and this point and this point are all common, and there is no obstruction in this. These are all 0 volts. Okay. Then from this point to this point you have one more node, because that's where the transistor comes into picture. And again from this point, there is from this point to this point there is no obstruction, so this line again forms one node. Okay, so these four nodes will very well define the complete spice netlist. Okay, these will be called your nodes. Now let's try to convert these nodes into a valid spice netlist, and let's do it in one by one, in one step. So we will give some names to these nodes. So these nodes, let us call it as N. This node, let us call it as N1 or VDD, and 0. The name, let's say, there is no restriction to give node names. It can be numerical values or it can be anything. So this is called as N, this is called as N1, this is called as 0, this is called as VDD. So let's give this name. Now let's try to use this node name. So we'll start with the MOSFET. So if you look into the MOSFET lies between four different nodes. But because MOSFET has got four terminals, it is lying between four different nodes. Similarly, resistor has got two terminals. It will lie between two different nodes, and same goes with voltage supplies as well. Okay, for example, if there had been a capacitance, it has two different nodes, or it has two different terminals, so it will be represented by two different nodes. The MOSFET has got four terminals. One is the drain, source, gate, and substrate. So this is how the MOSFET will be defined. You will be calling this as M1. M represents anything which starts from M, it is called as MOSFET, and XX can be any number. In this case we have given since it's the first MOSFET that we are looking into, let's call it as M1. Okay, so M represents a MOSFET. Okay, the next is VDD. So this is the drain area. So this node, since this node is called VDD, we have given this as VDD. Okay, the next node is gate. Since this is as N1, so this is called as this is the gate terminal. And the next comes to source is 0, and the source node is 0, that's why it's called as 0. And then comes the substrate node is 0, that's why it's called as 0. So the fashion in which this is written is, you give the MOSFET name, you give the drain, you give the gate, source, and substrate. It's DGSS. So drain, gate, source, and substrate. This is the order in which it expects the in which it expects the pins to be. This is basically the pin ordering. Okay, after that comes the name of the MOSFET. It's called NMOS, and this name is coming from something called as technology file. I'll get back to technology file in some time from now. The name NMOS is coming from the technology file. So along with the spice netlist, remember in the last video we mentioned that there are some technology parameters that we supply to the engine through a special file called as technology file. In that technology file we'll define NMOS. Okay, I'll come back to technology file in some time from now. I'll come back to NMOS. Okay, next is you define the width. The width has been 1.8 micron, which is clearly mentioned in this particular netlist. And next comes the length, which is 1.2 micron. So we'll start with a long channel length, let's say 1.2 micron. And there is an intention behind starting with the long channel length, because if I wanted to show you the difference when we try to simulate a long channel MOSFET and a short channel MOSFET. I wanted to bring out that difference very clearly. So that's why I'm starting with a long channel 1.2 microns over here, and then immediately we'll be shifting to a different node in the same spice setup. Okay, I'll come back to that. So 1.2 micron is the gate is the gate length, is the effective gate length. Okay, next is to write down the other components. So so totally we have four components. We have MOSFET M1, we have resistance, and we have two power supplies. So we have done with the first component. Let's move to the second component. It's very simple. Let's say resistor. So R, anything which starts from R, it's called as a resistor. And one x can be any naming, any numbers. It could be 24, 34, anything. We have given it as 1 because it is the first resistor that we are defining. Okay, now comes the node. So R1 is defined between in, which is the first node over here, and it is also between N1. So R1 is between in and N1, and the value of R1 is 55 ohms. So that was pretty straightforward. It's like a no-brainer. Next is the VDD, the VDD supply. So you have this capital V, small dd. That's your name. That's the name of the VDD. So anything that starts from V, that's your voltage source. It can be VDD, it can be Vin, it can be VSS, it can be anything. So anything that starts from V, that's your voltage source. Okay, and your VDD is between the two nodes, VDD and 0. So let's call it between VDD and 0. And the 2.5 is basically the voltage, the value of the VDD. So this is 2.5 voltage. Okay, similarly you have your gate voltage, which is V in, and it's again pretty simple. Anything that starts from V will be your voltage source, and after V comes XX. It could be in, it could be it could be DD, it could be VSS, it could be anything. So V in lies between two nodes, which is in and 0. So it lies between in, the node which is the positive terminal, which is in, and it lies, and the second negative terminal is 0. Okay, and the value of this VDD is 2.5 volts. Okay, so this was your spice net, this was your netlist that will basically represent the NMOS which that we're trying to simulate. That this is a very straightforward netlist. Things become a bit complex when we have more transistors, because writing down this spice netlist in a manual fashion might be a bit difficult, because when there are multi-million transistors in that case, to write down the netlist for each and every one of them, that will be a bit tedious. So we'll look into how do we tackle that problem as well. But once you look into a spice netlist, when you look into a single line in this spice netlist, and if you see something like this is what it exactly means. Okay, so there are other complex notions of spice as well, of the spice syntax as well, which will be coming when we go into complete circuit design. I'll get back to those things, but the next step over here is to now define the technology file. So once we have defined the netlist, next is to define the technology file. And technology file definition is pretty simple. We have partially talked about it in the previous video. It's basically adding all the constants that we have seen in the previous video into technology file. Okay, so that's what we are going to do in the technology file. So love, what we'll do, since I'm running a bit late out of time, let's try to deep dive into the technology file, and let's see from where this NMOS, how do we actually define NMOS and PMOS in the technology file. Let's try to do all this in the next video. Thank you.